So in this video, I want to talk about something called rational expressions and how to simplify them. And I also want to talk a little bit about how to solve absolute value equations. So we're going to start with something, it's called a rational equation. It's really just, not a rational equation, a rational expression. And it's really just a polynomial over a polynomial. So it's going to look something like this. Here's an example. Let's do k squared minus 16k plus 64 over k squared minus 7k minus 8. So in this case, it's a quadratic over a quadratic. And if someone asks you to simplify this, like maybe on your skills practice, hint, hint, what you'd want to do is you want to factor the top and the bottom and see if any terms cancel. So if we want to factor the top, I'll put our line here. We remember when we're factoring with a three-term thing, we've got 1, 2, 3 terms. What you want to do is take the factors of this term and write them off on the side, is how I do it. So you could do 1 times 64, 2 times 32, what do we got, 4 times 16, and 8 times 8. I think those are all of them. And what we want to do is we need to pick a pair of these that we can add or subtract together to get a minus 16. And in this case, I think our winner is going to be 8 and 8. Because what I can do is do k minus 8 times k minus 8. And that minus 8 and minus 8 is going to give me my minus 16. And when I take, for my last term, remember, we're thinking like reverse foiling. When I do minus 8 times minus 8, I get that positive 64. So I've factored that three-term numerator. For the denominator, we're going to look at this right here. We're going to look at the 8. And what can 8 be broken down into? Well, 1 times 8, 2 times 4. I think that's all we're going to get on that one. So what can be added or subtracted together of these pairs to get me a minus 7? Well, I think my winner is going to be the 1 and the 8 because I can do a minus 8 and a plus 1. So here I'm going to do k minus 8, k plus 1. And that's going to give me the minus 7 that I want. And a minus 8 times a positive 1 is going to give me a minus 8 here. And you could check this. If I foiled both of these, I would get back to where I was before. So now, if I want to continue this simplification, I can cancel out some things, right? So it's multiplication on the numerator, multiplication on the denominator. So I can cancel those out really nicely there. So I'm left with a k minus 8 over a k plus 1. And once I get to this point, there's nothing else I can do. It's really, really tempting to cross out these k's, but this subtraction and this addition make that impossible. We'll break algebra if we try and cancel those. So this is the simplified version of that rational expression. And why don't we go through, we could call this example 1. Let's do a second example here of a problem like this. So what if... let's use a different variable just so we mix it up a little. Let's do x's this time. So x squared minus 5x plus 6 over x squared minus 9. So here's another rational expression. So we're going to try and factor things and see what happens. So the numerator here, it looks a lot like the last example, where we're going to have 3 terms, so we're going to break the 6 up, and now that we're getting a little better at this, I won't write the terms on the side, but so in this case, we're going to have to use, we're going to have to use our 2 and 3, because we need to get x minus 2 and x minus 3 here. Now, you might have thought that you wanted to use the x minus 6 and x plus 1, but that would give us a negative number, a negative value here, right? So we would have gotten the minus 5, but this would not have been correct. So here we get the minus 2x, the minus 3x, and the positive 6. So that's what we want. Let's look at the denominator now. So this is a difference of squares. This is a two-term polynomial here, a quadratic, where you've got something squared minus something else squared. A difference of squares is what it's called. So a minus sign in between two things squared. In order to factor this, what we have to do, it's still going to split up into two binomials, but what you do, and it always works the same way, is you have to take the square root of the first thing. Here's the first thing. Take the square root of the first thing. And then take the square root of the second thing, right? 3 and 3. But you just make 1 minus and 1 plus. And what that does, if we were to FOIL here, we'd get x squared. Then we'd get minus 3x. Then we'd get plus 3x. So those x terms cancel. And then we get the minus 9. So that always works. Whenever you have a difference of squares. Here, I'll even write it here. Difference of squares. It will always factor that same way. It's the first thing squared and the square root of the first thing and the square root of the second thing. And what you need to do is just make one plus and 1 minus. So 1 minus, 1 plus. And that'll always work. So now I think we're ready to cancel some things out. So in this case, I think we can cancel those x minus 3's. And what are we left with? X minus 2 over x plus 3. And remember, we can't cancel anything there. Those x's look tempting to cancel, but we would break algebra, all right, because the plus and minus mess that up. So now what I'm going to do is shrink this so you can still see it if you want to. But now what we're going to do is an absolute value problem. So let's call this number 3. And the way absolute value equations are going to look is something like this. Let's just give this example, minus 10. So there's an equation with an absolute value in it, like you may see on your skills practice tonight. And what we're going to do is I want you to treat this absolute value. This is what you need to solve for first before you solve for x. So it's kind of two phases. First phase, we need to get the absolute value all by itself on one side. And then the second part, what we need to do is solve for x. So if we wanted to get the absolute value all by itself, first what we're going to do is subtract 1 from both sides. So we get 3 times 2x minus 10 is 12. Then we can divide both sides by 3. So we're left with 2x minus 10 is 4. Now we've got the absolute value isolated. Here's where the solving for x comes into play. In order to get rid of the absolute value symbols, we need to take into account that whatever's inside this absolute value could be positive or negative. So the way we do that is we say 2x minus 10 could be 4. So it could be the positive version, or 2x minus 10 could be negative 4, right? Because if it was negative 4 inside here, when we take the absolute value, we'd get out a 4. So both of those are valid. And when we go through here, now we have two equations we can just solve for x. So 2x is going to be 14. X could be 7. Or 2x is going to be 6, and x is 3. So there's our answer. It could be both, either or. X or 7. If we put them both in there, they would work. And that's going to be your mission for any absolute value equation. Isolate the absolute value first, and then give the plus or minus equation to account for all of the solutions.